Okay, so this one is page 386, number 7b. And it says, find the value of k such that the angle between these two vectors is 45 degrees. So we'll start here with the dot product formula. So that's A dot B equals magnitude A, magnitude B, cosine theta. So that's 1, 1 dot 0 K equals square root 1 squared plus 1 squared times square root 0 squared plus K squared cosine 45. So over here, this dot product here is equal to k. This is equal to root 2. This is equal to root k squared. And cosine 45 is equal to 1 over root 2. So root 2 and 1 over root 2, they cancel out. That means what we're left with is k equals square root k squared. Now, at first glance, this looks like a bit of a slam dunk. Oh, look at that. It always works. Because of the assumption that in this case, the squared and the square root are going to cancel each other out, leaving us with the square root of k squared is just going to be equal to k. Therefore, giving us k equals k. Therefore, doesn't matter what value we select for k. However, if we just do a couple of quick cases on this, we can either confirm or deny that assumption. So let's say we pick k equals 3. If k equals 3, then we get 3 equals square root of 3 squared, or square root of 9, or 3. So that means that one works. That's a check there. Okay, that's fine. But what if we have a k equals negative 3? If we do k equals negative 3, over here we're going to get negative 3. Over here we're going to get the square root of negative 3 squared. So negative 3 squared is 9, and square root 9 is 3. So in this case, it doesn't check. Because what's actually going on here is the square root of something squared, that is going to give us absolute value of k. So the square root of k squared gives us absolute value of k. That means what we're actually looking for here is when does k equal the absolute value of k? And that's actually a fairly straightforward question here. That is going to tell us that k is going to be greater than or equal to 0. So what we'll do is we'll just go back to our original problem and we'll sketch it out just to verify that everything works, and just to maybe go into a bit more detail about what we're actually seeing here. So the vector 1, 1, that's just going to be this guy right here. So the vector 1, 1 goes in that direction. That's A. Now, 0k is going to do a few different things depending on the value of k. It could do this and be this vector right here, 0k, for positive values of k. It'll be the 0 vector, or just that point there when k equals 0. And it'll be down here, 0k, for k being negative values. So when we look at this, the angle between two vectors is always implied to be the angle between vectors if they're positioned tail to tail. So if these vectors are positioned thusly, then that angle right there is 45 degrees if k is greater than 0. If k is equal to 0, then we have the 0 vector, and the angle between a vector and the 0 vector is sort of a trivial thing. It doesn't really matter here. So 45 degrees, the math works. So whatever. And then down here we have, for this vector here, we actually have that angle right there, or 135 degrees. So that's not going to give us what we're looking for. So that's just sort of going to confirm that this is actually going to be our answer. So there's the algebraic answer. And then down here is a little graphical answer. So that's that. And thank you.